kind of a live coding session, just looking over how AckCord does data decoding now, how it before, how it does it now, and such. For those that do not know, AckCord is a library for interacting with Discord from Scala. It used to be built on Akka. At this point, it is instead being built on HTTP. So let me see if I can share my screen, not just. Yes, that is the screen. So first thing, let's look at how this used to be done. Good old case classes. I think that is basically what everyone will just go for first. I have some API that is returning some JSON. I will just make a case class for this, and then I will auto-derive the JSON encoders and decoders. So this works, but it has several quite big problems. I wrote them down, so I'm going to find that.
Kathryn, quick point. We've got a point in chat. Can you zoom in a bit?
Oh yes, sorry. I remembered I should check this, and I thought, okay, what would be good? Yes, sorry. So I forgot that. Sorry about that.
Cool.
If I forget again, do just remind me. I do not want to go into presentation mode because we're going to access multiple files. Anyway, so this works. It is very, very simple. What are the problems with it? Well, sometimes the Discord API docs are not machine generated. They are user generated, and they are user written by volunteers that basically just go in. Sometimes the Discord developers go in and give a blessed doc, so to say, but often it is just user going in and yes. So what the problem is that these types that we have here, they are not always correct. The most common mistake is that an option is missing here. And what happens when something is nullable and it is not specified as nullable here, just everything crashes, and if an event was sent over, if an object was sent over the gateway, you now lose that entire event in gateway. You cannot do any code reactions to that again, anymore. If it was received from an REST request, you now don't get that object, and you can't do what you wanted to do with it. It is AckCord tries to handle this kind of better. For like enums, what it does, if we can find an enum that is channel, probably has channel type, which I need to zoom in again. So here we see again, this is an enum channel type. So this is a sealed abstract class using enumeratum. We have all of the case objects here, and then at the bottom we have case class unknown, and then it just tosses any unknown enum into this. This works wonderfully for enum. Sadly, it doesn't work for like objects. So what happens when we change this type? Well, we break binary compatibility. That is not fun, and it is one of the reasons why AckCord has been stuck on 0.x forever, because I do not know how I can release 1.0 without bumping the major version every single release, basically. Not fun. Sometimes everything decodes just fine, except this object here. The library hasn't been updated in some time, and a new field has been added. and developers want to access this new field, but they can't. And they really just can't. So they require that the library is updated quite frequently all the time. And sometimes also, I don't want to expose something in the library because it's technically not documented. But if I don't expose it, then a user can't interact with it, which places me in a very hard place. Next off, performance. Discord sends you a lot of JSON. They have lots of ways to reduce the amount of JSON you get, but it's still a lot of JSON, and that means the time you take to actually decode these objects is probably wasted compared to how many of these fields that you use. Like, I would guess that of all of the JSON that a normal Discord bot gets, you use just a few percentage of those fields. So if we could just not decode everything and just decode what we need, that would be wonderful. Last problem, which is not that big of a problem, just more... You see this partial application here? It is the exact same thing as this, with everything except some fields is nullable. Discord likes to do this a lot, where it's like, oh, it's this object, but it also has this type here. I think if we jump into the gateway data, I said, 24, yes, we can probably find some object here, which is just x with y fields. So let's see. Here we have yes. No, wait. So here, good rule of thumb to find these is just remember. I always comment stuff with this with remember. So remember to edit raw guld member when editing this. This is raw guld member with guld. It is exactly like raw guld member, but it has a guld field in it. This is not fun to come on. This is not fun to try to keep these the exact same, and sometimes you forget. And oh look, there's a edit interaction guld member when editing this. So there's another one, and this gets kind of tiresome when we have tons of these. So let me just switch over to AckCord 2.x. So what AckCord 2.x does is that we have this is what application looks like in 2.x. We have the JSON, we have a cage which extends this magical Discord object, and then everything is just accessing this, and we have to get around no copy. We also have with x here. To note, AckCord 2.x uses code generation to get all of this, because it would be a lot of code duplicated otherwise, but you can use some of these ideas that will do without code generation. So let's just go ahead and rebuild this from mostly scratch, I guess. To note, before we get at this, we have two types here, JSON option and undef or. Undef or is used if a field is either undefined or present. AckCord 0.x just groups all of these under option. We have JSON option, which is if a field can be null, undefined, or option. Yes. First thing we see here, we're missing a missing field exception. So I will just go and copy that into this. Now, some of you might be kind of a bit horrified here. Like, we have an exception for a missing field. Yes, we do, because it is far better to fail as close to a user using a field that is not present or has the wrong type than just erroring way earlier. Because if the user doesn't need this field, for example, this doesn't, like, just getting this doesn't really happen. Some things in AckCord is going to throw missing fields exception left and right because they inspect basically the entire thing. That's fine. Yes, missing field exception, to make it easier to work with, takes a has a more like detailed description about what went wrong. So which we construct with this default constructor here. So normally a field is either missing or could not be decoded. So we have error messages for those: missing field name on object name, or just found field on object but could not decode it. And this gives, when something is missing, it clues the developers in on what is wrong. Can I fix this on my own, or should I just wait for a fix, for example? So next, we want to make our Discord object class. Let me just... So the first thing we want here is that we want the JSON that we are going to be operating with. I'm using source here, but you could do whatever else. And we want to get these out. So we could, now ideally what you will be able to do is that you will be able to do type foo equals Discord object and then use a structural type because we're in Scala 3, and just say value ID is int. And then just have this extends selectable here, and then write out the function def select dynamic, taking in the type that we want, taking in the name of the field, taking in an implicit decoder, A, and then producing A. Yes, again, we are throwing exceptions if we don't find a field. Sadly, this doesn't work. The Scala compiler will does not want to actually fill in this type here. It just it just doesn't do what we want here. We can brainstorm ideas about how to get around this, but for now, no selectable. We'll still just call this select dynamic because it's basically what it's doing. So how do we implement this? Easy and simple. We just so what we do is that we convert JSON.hCursor.get a name, and then if this fails, we throw missing field exception.default. With just the field is the name of the field, and the object is this JSON. So we get some thing here. We need to handle some bit nicer because undef or undefined and JSON undefined also has integrations for missing field exceptions. So we just match on this if it's an undef or undefined. We need to populate some fields to get nice and juicy this should not be a JSON, it should be a string. We need to populate some strings to get nice and wonderful error messages, because error messages are wonderful, and we want them to be good. So if it's you might like, what AckCord did at first to you was that like JSON undefined should be in like object, right? Well, having it like encoding what you were expecting to find the object makes it a lot nicer to like just walk with. If you then call get on this JSON undefined later, it makes it much easier to just just walk with. So this should work, and what we could then do is that we could do class foo takes in a JSON, extend this code object JSON, and then we could have def id int equals select dynamic int id. What I like to do is that I like to annotate these as inline to get back some of the, to reduce the chance that if I ever have to change this type, to slightly reduce the chance that a user will feel that a user will get the class exception, because it is something different than what they used to be. So what we are basically doing here is that we're letting the user decide exactly what they should be getting from a field. So we kind of turned everything around. So normally the one that is defining the object also defines what fields are on it and what type those fields are of. In some ways, the user is defining what those fields are and what they're named and stuff, because in effect, they should, hopefully at least in the bytecode, just be calling select dynamic, which will not change. We can extend this further with other stuff to just augment this further. So the first thing I like to do with this is that I want to have like, now first off, we called class foo here. This is important for, like, we could just have an opaque type with like these as extension methods. Why I like to do class here is that users like to match on stuff and just see, oh, is it a channel? I only want channels. And doing class here keeps things mostly structurally typed, but a tiny bit like normally typed too. This does make, like, a user might intuitively think, oh, I can just cast this to something else that I want instead. That won't work, so we need to re-implement casting. We have this code object companion which will store that. This will also store the encoder, which we can encode and decode this to just easily, so that any Discord object is also just implicitly has a JSON encoder and decoder. So what we need here is that we need a function to just construct our Discord object. So I call this function make var, which takes in a JSON object and then produces our object. From this, we can then also have our codec. And I can just start code. Let's see. So what we can do now is that we can, this is stuff that we'll add later. So what we can have now is that we can implement our casting function, which I call retype. So we want to retype this to some other object. So we take a companion of this thing that we want to retype it to, and we just call on the companion make var with the JSON that we have. And at this point, we're getting truly into the structurally typed stuff. So for objects for class 2 here, we extend this called object companion. And then we could, we need to make raw equals new foo JSON. And then we could have another class, foo here. These do have a bit of boilerplate to set up, which is why AckCord uses code generation for all of this. But as I said, you can do these things without code generation too. I mean to name this bar. And then we have an object bar extends companion with bar. We have a make raw function which calls new bar with the JSON. And now let's say that we had an foo here, and we want a bar. We know that these things have the same fields. I kind of discourage doing this in user code, but you totally can. So we can just call foo dot retype to bar. So why is retype useful? Well, let's say that bar, it actually has all the fields that foo has. It is just an extension of foo, as I call it. So what we can do then is that we can just have a function called foo here, which returns a foo, which just retype this as foo. And then now a user can just, if they have a bar and they want a foo, they can just, these names are totally messed up now. They can just call the function to just retype it to that. And now this works as you would expect in terms of JSON encoding and decoding too. That like, so we have nice, nice and types, and we also have like name stuff, like, but they're still extensible and stuff. So the next thing to like think a bit about is performance. Some fields are accessed a lot, so we might want to cage some of these. So what we do is that we take in a start cage and we just convert this to a mutable map. For some stuff, it is nice to have a function which just gives us a copy of the cage too. Then for just select dynamic function here, we can just call cage.get or else update name, and then we place our body in here, and this should, hang on, now I'm missing something. Yes, we want to move these costs out. And this is now, for the make var function, we now just want to have the cage that we're going to start with. And this is for that map.empty call comes in. And then we have lots of spaces to add the cage. Yes, and then also just why am I typing this out? I have it copied. Who knows? Yes, now we have a nice... Oh, and then we also need... like, the kind of tempting thing to do here is to just to pass in the cage. I think that will technically not be correct. So what we do instead is just pass in an empty object. So we can also just have a few like functions to add an object to it and this. So if we want to add another field to it, for example, which is the baseline of all of these with X functions that we saw. So I will just copy paste that code and go over it. So we have the most simple, for God's sake. For the simplest case, we have just object width. I guess object with JSON is easy to explain. Object with JSON, we just call make var with. This is that the is this a bug in live coding session? It might be. Let's see. Yes, congratulations everyone. We found a bug in the live coding session. Anyway, so we just merged these two JSON objects that we found. We combined the cages because if we're adding something, we know its value intrinsically when we add it. So we can just easily do that. Import these. Then we have all of these other functions which like do special handling, because like if we're adding with an undef or if it is undefined, we actually want to have the object without that field. So we remove it instead, which is what all of these other functions do. But yes, so now we can also have our function inline def width id int foo equals object width, and then we call pass into companion. This we want to update the int id field, and we want to update it with the id value. So yes, it looks like we're running kind of out of time. If people are interested more in this, there is, if I can just get, so feel free to just check out how AckCord's actual this code object looks like. You can just find it in AckCord base this code object here. It has a few more things to construct these facades that we've gone over, because currently we've just gone over using them. not constructing them. So if we see in application here again, to preserve binary compatibility, each major version gets its own make function. Last thing that AckCord 2.0 does to hopefully make the binary compatibility problem easier is, which is why I asked before about not semantic versioning, is that it just uses epoch major minor version patch, because then it's much less scary to bump the major version now and then if you actually need to. Anyway, that is mostly it. We didn't get that much to brainstorming extra ideas. The extra, how this all started, had lots of those ideas, but basically it involves just what if we could make select dynamic work by taking in, like, by making the name a literal type and then looking up what type we want to use based on that. If we did that, maybe we could, for example, also just version, like have something like in user code at the top level, just use use AckCord version equals AckCord version dot 2.1. Version 2.1, for example, and then it will just infer the correct types, or, well, not use, but give an AckCord version equals AckCord version dot 2.1, and then it will just look up all the versions that are applicable for that version, and then if later down the line the types change, they only change once you actually update this thing, for example. So that's one idea, for example, of just like walking through, if you further on this idea.
Cool.
Yes, just tons of ideas on getting preserving binary compatibility in a loosely typed world.
Well, thank you very much for the presentation. Heaven knows